Hello friends, I welcome you to my YouTube channel Maximum. So in today's video we will discuss about stress and strain, which is very basic of the mechanics or strength of material. And in many subjects you will come across the terms stress and strain. So first of all we will define what is stress, then what are the type of stresses. We will try to understand it. Then we will learn about strain and what are the various types of strains. After that, we will learn about the modulus of rigidity and Hooke's law. So let's start. First of all, what is the stress? So suppose this is a member, and suppose we are applying a pull in both direction. Then the material, suppose this is made of iron. So if you pull it from both sides, then it will not easily elongate because it will offer some resistance. Then suppose this is material. If you are pulling in this direction, then material will try to pull back in this direction, and in this direction it will try to pull in this direction. So the internal resistance offered by the material against the applied force is called the stress. So stress can be represented in two forms. First is total stress. What is total stress? So total stress is, suppose we are applying 50 kilonewton force. So total stress in this will be, suppose this material is not getting elongated and it is maintaining its shape. So internal material of this beam will offer a resistance of equal amount to the external load. So total stress will become 50 kilonewton. So it will be like this. Suppose we are applying 50 kilonewton from outside, 50 kilonewton, then material will offer 50 kilonewton stress in opposite direction. This is when the material is stable and it is not elongated much. Suppose this material is getting failed, it is being broken from in between, then it means that it is not able to offer the 50 kilonewton resistance. So internal load will become less than 50 kilonewton. It will become equal to when the ultimate stress of this material. So this is total stress, and one is unit stress. So what is unit stress? Generally we represent stress in form of unit stress. Suppose sigma is the stress, then it is represented by P by A. So this was the member. Suppose, let's remove this. Suppose this was a beam or a member, and we are applying a pull of P Newton from one direction, and suppose this is a cylindrical. So this is area A, this is cross section area of this beam, which is A. Then stress will become, the formula for stress will become P by A, which is P is external load applied and A is cross sectional area of the material. So this is load, this is stress. So what is the unit of stress? See, load is represented in Newton or kilonewton, and area is represented in meter square. So unit for stress will be Newton per meter square, or we can if area is very less, then we can also represent in Newton per mm square, or suppose load is very large, then we can write it in kilonewton upon meter square. Okay, so this is the unit of stress. So let's see what are the types of stresses. First one is tension, then compression, then shear. These three are called the simple or direct stresses. So what is tension? Tension is, this is a member, cylindrical member, and we are pulling outward. Means if we are pulling, then material inside is getting elongated, or suppose it is not getting elongated, then it will become come into tension. It will try to pull back. Suppose you are pulling a rubber, then when you pull it extremely till a extremely large extent, then it tries to come back. So that property is called the elasticity of the material. So tension is when we pull outward. Compression is when we try to press. Suppose this is a member and we are trying to apply force to press it. So this is called compression. What is shear? Suppose this is a member, this is a member, and we are trying to apply force from here and try to apply force from here, and these two are not in the same axis. Then this will try to break material from here, somewhere here in between. So this is called shear stress. In what cases shear stresses are occur? Suppose this is a plate, this is also a plate, and these two plates are held together with a bolt. And suppose we are applying a force here, suppose we are applying a force here, then what will happen? This material will try to break from here, because it is supported by plate here in this area, and it is supported by plate here. So weakest point is here. So material will try to break from here. So it will be a shear stress. See, the axis of the bolt is vertical, but load applying is in different direction, and it is not in the same axis, and material is trying to break from here. So this is called shear stress. Apart from this, there are bending stresses. Suppose this is a beam, this is a beam, and it is supported here, it is supported here, and if we are trying to apply a force here, then it will try to bend like this. So the stresses developed because of this beam trying to bend is bending stresses. And what is torsion? When we are trying to rotate something which is fixed. Suppose this is a shaft and it is fixed from here, and we are trying to rotate it clockwise or anti-clockwise, any direction, then it will become a torsional stress. And these two are called indirect stresses, bending and torsion. And third one is combined stresses. Combined stress is what, if we mix all these, or suppose we take combination torsion plus bending, or shear plus bending, or compression plus tension plus torsion. If we mix combination of these three, then it will become combined stresses. Now I hope you understand up to here. If you have any doubt, then you can ask in the comment section. Then we will read about strain. What is strain? So you are saying that we are trying to apply, when we are applying a force on a material. Suppose this is a beam, and we are trying to apply force P here, force P here, and the material is getting developing stress to resist this force. So what happens is, all the materials have some type of elasticity. Some has less, some has more. So when we pull this material, then it will try to elongate. So suppose this L was its initial length, and this delta L is amount of elongation. This is delta L, this length which increased from the initial length. So what is strength? What is strain? Suppose strain is E. E will be equal to delta L upon L, or simply we can say that change in length divided by original It can be minus also, negative also, because suppose we are applying compressive stress, compressive forces, then it will try to contract. So in that case, it will become negative. So, but this you have to be careful that this is only linear strain. We are considering only one direction, but strain can be of many type. Like say, here we have tensile strain. Tensile strain, as I told you, when we are applying a force, then this material is trying to get elongated. This is increase in the length. So then tensile strength will be delta L by L. Then it is compressive strain. Suppose this is the member and we are pushing from both sides, then it will try to reduce its length, it will get contracted. So final length will be like this. Suppose this is delta L and initial length was L. So compressive strength will become delta L by L, but it is negative in opposite direction. Okay, then we have shear strain. What is shear strain? Shear strain, suppose this is a rectangular plate and it is fixed here on lower side. Suppose this is A, B, C, D. When we are applying force here, suppose we are applying force P here, then this will try to get deformed. Suppose it is bending like this and it is becoming D dash and it is becoming C dash. Then what is the shear stress? Shear strain. Shear strain will become, ES is suppose shear strain. The shear strain will become CC dash divided by the BC. Or suppose this is angle phi, then it will be equal to tan phi. Okay, if phi is very small, suppose this is angle is very small, because we are showing this so much deformation here CC dash, but in reality suppose this is metal, then it will not deform so much, it will be very less. CC dash will be very less compared to BC. So if tan phi is very small, then tan phi will tend to be equal to phi radians. So ES will become tan phi or phi radians. This is shear strain. Similarly, there is volumetric strain. So in volumetric strain, what will be the value of strain? It will become volumetric strain. Suppose it is EV. Volumetric strain, it will become change in volume divided by original volume. Suppose there is a cube and we are getting forces P on all the surfaces. It has 6 surfaces. Suppose we are getting a forces P from all the faces, and its area suppose initially is V, and area has become V minus delta V. Delta V is reduction in the area, then volumetric strain will become delta V divided by initial volume. This is volumetric strain. Volumetric strain can also be represented as sum of all the linear stresses. Strain EV is equal to EX plus EY plus EZ, where Ex is strain in x direction plus Ey is strain in y direction plus Ez is strain in z direction. So if we all add all three, then we will get volumetric strain. Now another important thing is Hooke's law. So as you can read here, Robert Hooke, an English mathematician, conducted several experiments and concluded that stress is proportional to strain up to elastic limit. So as you may know that when you apply stress on a material, then if you will draw a stress strain curve, then up to certain limit the material strain will be proportional to stress, but after it will start to fail, material will start to deform, then it will not follow this rule, it will break like this. Okay, so the limit up to which it follows the strain proportional to stress is called Hooke's law. Okay, so suppose P is stress as shown here and E is strain, then P is proportional to E, strain is proportional to stress, and if we put the constant here, then P is equal to E into E. Here E is called constant of proportionality, which is called modulus of elasticity or Young's modulus. It is named on the name of scientist Thomas Young. So this is called Hooke's law. Here stress is proportional to strain. Here P is stress, E is Young's modulus, and E is strain. So I hope you understand this problem and concept up to here. If you have any doubt, then please ask in the comment sections. Thanks.